This is the first practical looking at rates of reaction, and this is surface area. So the whole principle of this is that we're going to produce some gas through a chemical reaction. We're going to produce carbon dioxide by reacting calcium carbonate and hydrochloric acid together in a conical flask. Then we're going to deliver the carbon dioxide through a delivery tube to displace the amount of water in a measuring cylinder. So here we got small chips. We're going to use the same amount of same mass of chips each time. So smaller pieces in effect equal bigger surface area because there's more atoms available to collide with the acid. So we put the stopper in, the chemical reaction has begun, gas is being produced.
Mr. Garrett's going to see this video.
Then while the gas is being produced as quickly as possible, as shown in that one, you're going to deliver those bubbles of the carbon dioxide gas through the water, and that's going to displace the water to equal volume of gas. So we can measure the amount of gas produced. There it is, the bubbles, bubble, 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 carbon dioxide. Okay, the reaction's taking place, lots of fizzing and effervescence. So that is the chemical reaction occurring. I can see that because I got bubbles produced. And as you can see, it's displaced a certain volume of water, which I can then measure. We're doing this for 5 minutes. I'm going to collect the results. Gas produced over 5 minutes. Then we use bigger pieces, same mass of copper carbonate or marble chips, and we're going to have the same reaction, same concentration of acid, and we're going to see how much carbon dioxide that produces in the same amount of time, 5 minutes. So you can see that the limiting factor on that one was the amount of acid, because the marble chips are in excess. Now, CaCO3 is calcium carbonate plus hydrochloric acid. This is a neutralization experiment. So we end up with CO2, we end up with a salt, which in this case is CaCl2, calcium chloride, and we also get H2O. Now we've got to try and balance this. So we've got H2O, so we're going to have two hydrogens in your hydrochloric acid. We've got loads more on this coming. We're going to look at concentration of acid, and we're also going to look at temperature of acid and how that affects rates of reaction. Please like, subscribe, and I'll put some more videos on. Peace and love.